My name's Clint Carlson. I work at the University of Colorado. I'm the program manager of digital education and academic technology at the School of Dental Medicine. My big focus is really on simulations, building VR, AR, 3D models, and how we can enhance learning and teaching and collaboration and community building and all the good stuff that comes with education, but using technology as a tool to instigate it, reinforce it, support it, build it. I really see a lot of what I do either in VR, AR, or 3D modeling as an extension of the maker movement and the maker space. So sort of that energy behind of creating, of making, of building stuff. Difficult to do collaborative work in our remote environment. So we've got a unique opportunity to bring in some tools to kind of bridge those gaps, but then to also bring those technologies forward as we return to normalcy. So today's workshop this afternoon is going to be around 3D modeling. So you don't need any experience to be doing this. We're going to be doing this in a free-to-use platform called Tinkercad. I'll get into the details of that once I start my presentation a little bit. Got about 25, 27 people here right now. It's getting a little crowded to just have open voice chat at any time. But if you see a moment where I'm doing something or you want to expand on it or ask a question, feel free to drop that into the chat if it's not something time sensitive. If it's something very specific about what I'm currently talking about, well, feel free to unmute yourself. I think we could be pretty loose. If it gets out of control, we'll change the rules, but let's keep it loose and organic for now. All right, let's get my share going. All right, again, this session is building your own 3D object to create and view in augmented reality. So we're going to see that happen. We're going to build 2 projects today, unless time totally gets away from us, but 75 minutes is a great amount of time to be jumping into this. So we're going to be creating a die, the singular of a dice. So all of us are going to create a 6-sided die, kind of by default, and then we're going to be a little creative with it. We're going to be creative into how you represent those 6 sides of that dice or die. Once we've completed that and shared a little bit with each other, then we're going to get into creating a name tag, a little tag that we could attach to a zipper or a backpack. And we'll kind of talk about what we can do with these objects besides just view them in augmented reality. A really great piece of 3D modeling is the open source nature of it. There's so much we can be doing with these pieces once we've got them built up. Here are our learning objectives for today. This is the plan. I'm not even putting this in presentation mode. Let's keep it loose. So you are going to understand the language of 3D modeling. So we're going to be talking about the XYZ axis and shapes and holes and negative and positive space. You're going to understand how to navigate 3D space on a 2D screen. So what's going to be easiest for this is if you can be viewing this on, say, an iPad or a mobile device while you're actually building on a laptop or a computer. I'm on a Mac, so when I talk about things like holding down Control and clicking to rotate, that might be a slightly different keyboard shortcut if you're on a Windows machine. So just be prepared to maybe hold down a different button when you're turning things around and you're getting these things going. Tinkercad's pretty intuitive, so we shouldn't have much of an issue jumping into those pieces, but we might. So feel free to drop those things into the chat or into the voice. Just kind of the dynamics of making over a Zoom call. So you're going to develop your own 3D dice for sure during this session, but hopefully we'll also get to the name tag piece where we can talk about text and some other spots. Then we're going to see how we can view these models in augmented reality, almost as a way of prototyping what these things would look like in real life if we were to 3D print them or something. And then we're going to talk about the wider application of these 3D models. Again, the nature of 3D modeling is inherently open, which is one of my favorite things about it. Big open source nerd. All right, so today we're going to be using Tinkercad. It's owned by AutoCAD, which is, if you've heard the name, CAD is computer aided drawing, CAD, and they are by far the world leader in doing this stuff. So many engineering and architecture and planning projects and schematics are done using the super advanced AutoCAD software. And Tinkercad is, I think it's fair to call it a scaled down version of that. It's completely web-based, so we don't need to download any software or deal with any of that until we want to view it on an iPad or something in augmented reality. But all of the creation and everything all happens in the browser. So we don't have to save anything. Everything's going to auto-save as we go. I mean, it's going to feel like a dynamic web platform. But know that the engine behind it is extremely powerful and being used by companies and engineers all around the world to create incredible buildings and roads and structures and infrastructure all around us. Pretty powerful stuff. It's also a good extension. If you or your students were to outgrow Tinkercad, if you got really, really into 3D modeling, then there is a path to go from Tinkercad into another product that I create called Fusion 360, and then eventually maybe even into AutoCAD if you get really, really serious about this and turn it into a career. So let's get started. This will take a couple of minutes because we all need to individually do this. If you're going to be doing this along with me, we need to go to tinkercad.com and create a personal account. You'll sign in with your email. I think there's a couple of boxes asking your name, maybe some basic demographics, and then it'll push you into Tinkercad. And there'll be a big screen that says, ready to learn the moves? You can just X out of that because we're going to be learning a lot about Tinkercad as we build through this, and we don't need to go through their tutorials. I'll jump to Tinkercad so you can see the screen that you should see for us to get going. And we're all good. So we'll give everybody a couple of minutes to do that. If you're just following along, if you're not making with us, come back in, I'd say about 3 minutes, and we'll get rolling. And this is the screen where you will end up once you are logged in. So I've created a brand new fresh account so we can do all of this from scratch. And I have a prompt to create a new design, which I haven't created at all yet in this account. Checking this in the chat. I'm doing this on the iPad. It seems to work. You can do it on the iPad. The app, Tinkercad app for the iPad is pretty well developed. A lot of the shortcuts and the keyboard configurations and where I'm clicking might be a little bit different for you than how I describe it. But again, iPad's pretty intuitive. I mean, when I'm saying click, you're tapping. If I'm doing a right click, that's usually a double tap on the iPad. And how you navigate may be a little bit different, but should be very, very close. And while we're getting everybody set up, I'll talk a little bit about how I wanted to facilitate this for an entire classroom full of people. Tinkercad does come with a classroom feature, which is fantastic. So I could have set this up and created templates and be able to jump in and view your designs as you build that up. Those are things you can do as a facilitator inside of Tinkercad with students or colleagues or whomever. But it does require all those individuals to already be in Tinkercad, and it requires me to give all of you a nickname in Tinkercad to pre-populate you into that course. That doesn't work very well in a workshop where I don't have a roster of everyone who's going to be attending. So I couldn't set that up the way that I would if this were a real class and you were coming to my classroom and I had your attendance log. So just know that the way that we're doing it is a little more independently, where we all have our own individual login, but there's absolutely a fantastic path for creating classes. And I'll just click in there so you can see it a little bit. We could have created this class and I would add students, but I would, again, have to have these students here in advance instead of the ad hoc nature of this where everyone's just joining. So just know that type of facilitation is there and is awesome. So that way you can assign assignments to your students, have them working on things, and then you'll be able to jump into any of their projects and see their progress, give them feedback, make tweaks to it. Pretty powerful kind of class collaboration piece in there. But again, does require that little bit of heads up. All right, I don't see any concerns in the chat, so I'm going to assume everyone who's going to play along is logged in and ready to go. They're on this default screen. We're going to start with just clicking Create New Design. And this is going to open us up into an empty work plane. So we've got the empty work plane, that's sort of the desktop where we're going to be making stuff. And one way to think of this is a physical desk and a whole bunch of Legos that can come in unlimited amount of shapes and sizes and can be changed and modified. But it all kind of begins in this empty space. So let's talk a little bit about the interface and the navigation. We've got the big empty space in the middle. Of course, this is our work plane. This is where we're going to be doing most of our stuff. There's little details down here where we can edit the grid, make these grid lines smaller. For the purposes of this workshop, that's not really necessary. But if you get into projects that are a lot more detailed and precise, you may want to be tweaking that as well. We got in the chat. Okay. All right, so way we can, first we need to be able to just rotate this because we need to be able to view this work plane from 360 degrees because we are doing 3D modeling on a 2D screen. So that by nature lacks some physical intuition that you might have. But we'll get the swing of it real quickly. So on a Mac, I'm holding down the control key on my keyboard and just clicking and dragging. And it allows me to rotate this any direction that I want to. So I can view this from beneath, I can view it from the side, from the top. If I use my scroll wheel or however you're scrolling on your device, I can zoom in and out, which is great. I can get in really, really tight on details and I can zoom way, way, way out and see the big picture. Another way to rotate this around is in that top left corner, there's this cube. And this is kind of a 3D representation of the working place that we're in. And I can click this cube and drag it around, and it's very similar to how I was holding control and dragging this around. But also gives me some quick shortcuts. So if I real quick wanted to see this from the bird's eye view, yeah, I could hold on control and kind of rough that out. Or I can just, on my cube, click the top center, and it lines it right up. I can click those on the corners. I can click top corners and view it from that angle. So lots of ways to view this. Along that left sidebar, along the beneath the cube, there's a handful of buttons. So we can zoom in and out this way. This button fits everything into view. So this won't do anything until we have things on our work plane to fit into view. So we'll come back to that. And if we click home, it just defaults our traditional view, kind of looking down at that angle between the front and the top. And then we're going to start along our left, along the top of it, we've got some tools that are grayed out right now because they refer to things being done on the work plane, which we haven't done yet. But know real quick that there's a copy, paste, delete, undo, redo. Again, there's no saving in Tinkercad because we're web-based, because the nature of this is saving to that Tinkercad cloud in real time. Which is really great when if you build up that classroom, you can jump into different student projects and see them working on things in real time. But what's great for us is that it just saves. So no need to worry about version control or any of that nonsense. Along the right side, we've got some tools up here. Some of these we're going to get into, some of them we won't. But we could import a 3D model. We could export what we create here as a 3D model and bring that to a 3D printer or to CoSpace's a virtual reality program or just to send to somebody else. A little bit below that, we've got basic shapes. So this is primarily what we're going to be using today are the basic shapes. And if you look around your environment, wherever you happen to be, this is a good exercise I do with younger students is all right, look at this table and now break that down into its most basic primitive shapes. And they start to realize that everything is made out of basic shapes. You start looking at things and almost everything, it boils down to it started as a box or a cylinder or a sphere and had additional shapes tacked onto it or stretched into it until it becomes the unique shape that it is. So we see those sort of things all the time. So we've got a box, a cylinder. We see a box with these kind of gray stripes. That represents that this is a hole. Maybe yours is a little so sort of the negative version of the positive shape that we have here. So know that we've got physical, we've got solid shapes, and we've got hole shapes. And by using a combination of those things, we can carve holes in the middle of solid shapes, and we'll get there. So just know that it's there. It's part of our basic shapes toolbox. There's some other rough shapes. We'll use the text a little bit later in the session when we create those name tags for ourselves to 3D print and put on our book bags.
She has a lot of hair, and we're gonna do
there's quite a bit. I mean, we get into rings. There's a die in here, which we are really not going to use because I like to make it a little more challenging. And we'll start with our box to create our die. But within this, we're not going to get into these, but there are all kinds of shapes that come preloaded with Tinkercad to allow you to do all kinds of things. So if you are doing a circuitry prototype in Tinkercad, all those components and assemblies are there. Smithsonian has contributed some 3D models of dinosaurs, and I mean, it's just, you can click into these and see all kinds of things. Here's a bunch of little, here's dinosaurs separated into a bunch of parts. So you can build this dinosaur almost like Legos. But again, we're going to stick in our basic shapes over here. Even our text and numbers are quite nuanced with different fonts and different preloaded letters. We don't have to look at the letter A and figure out, all right, well, what shape does the A start as? And then we carve that out. We probably start with a pyramid, squish it in, carve out that hole that's the hole in the top of the A, or Tinkercad gives us a little shortcut. So make sure we're in basic shapes. And our first project today is going to be creating a dice or a die. So we need to kind of visualize in your mind what consists of a die. We know that it has 6 shapes, it's mostly a box shape, even though it may have the curved edges. And then it certainly has indications on each side as to what side of the dice is showing. So 1, 2, 3, 4, 5, 6. And the challenge for this group is to create that die along with me, but instead of using the 1, 2, 3, 4, 5, 6 dots on each side that I'm going to be doing to show how the holes and everything works, your challenge will be to represent the 6-sided die in a unique way. Without giving too many ideas away, I've had some really creative ideas come from students, where some students just represented numbers in a different language. I've had students who represented the 6 sides of the die in Braille. So somebody with a visual impairment could touch the top of the die and quickly identify what number is on top. I've seen it's just represented with interesting objects. Like I had a student who is really into porcupines. So we put 1 porcupine on the one side, 2 on the other side, 3, 4, 5, and then the 6th side had 6 porcupines lined up. So totally creative, totally open-ended. And again, this is just about understanding the tool and the interface and understanding the potential of, you could really 3D model virtually anything inside of Tinkercad. If you got into something really, really complex, you'd probably migrate it into a more advanced 3D modeling software that isn't web-based. But it all begins here. And philosophically, 3D modeling is all the same. Essentially, when we've got 3D models, so this box I'll just drag in from my side, we can see that this box has sides, it has points. The thing to understand maybe fundamentally about 3D modeling is that it's just geometry. That a 3D shape is really computer understanding. We've got a X, a Y, and a Z axis that make up 3 dimensions. And where are there points in those dimensions, and where do those points connect to other points? And by just drawing that logic out, we can create a square, or we could create a cube just by putting points in the right place and saying that they're connected. That is essentially all a 3D model is a huge collection of multiple points and their relationship to each other. As far as the colors and the textures go, that tends to be a different layer of 3D modeling. Sometimes that's merged together, but to be pure about 3D modeling, it's really about constructing the shape. What's really great about that is that I've essentially described vector-based graphics to you. So what's great about this is that there's nothing to pixelate in here, because there are no pixels. It's truly points. It's geometry. So when you design the die that you're going to be designing today, that die could be scaled to the size of a building and lose no resolution or detail. because it's just multiplying those numbers times each other, but there's no resolution or quality lost the way that you would get from like taking a photo and resizing it so it's much larger than its resolution, and it gets all blocky and messy. That's a huge benefit of 3D modeling and using 3D models inside of simulations, is that they scale so easily and nicely.
So Clint, we have a question in chat asking if the app allows for materials. That's from Jesse.
Yep. Fantastic question. Tinkercad isn't designed to handle materials, so it really just gives you these colors to identify pieces inside of it. But this is really to create the actual model itself. If you wanted to add textures or colors or other pieces to it, your best bet's probably going to be then exporting your 3D model into a more advanced, sophisticated software that does handle that piece of it. And there's plenty of open source options of that. Blender is extremely popular. But Tinkercad, because it's owned by AutoCAD, would also allow you to send this to Fusion 360, which is a more advanced 3D modeling software that does come with those textures and the lighting and kind of the more advanced 3D modeling things you might be looking for. So back to our cube. Let me start that from the beginning. So I've got my toolbar over here, and I've got my work plane that I can zoom in and out of. I'm just scrolling in and out. And we're going to create this die. So our basic shape is going to be this box. And that's already not unlike a die, right? I mean, a die is a pretty primitive shape. If I click on this box, I get some options. So I can change things. So right now it's length, width, height are all 20 because it is a cube. But I can start dragging these things and make it not a cube. I can bring that back, type in a number if I'd like. The radius I can change, and this will give that roundness. We definitely want that on a die. So I'm going to bump that. 1 is probably all you need because we're just looking kind of for those soft corners to appear like a die. I haven't seen very many sharp die in my life. So that's a good first step. That gets us going. All right, so now we need to actually define which side is 1, 2, 3, 4, 5, 6. And we'll do this through 3D modeling. So our next piece, I'll grab this die, and I can drag this around on the XY axis, or I can raise it up and down using the arrows. I also get these fine tools in here that will allow me to grab a corner and drag pieces out. If I hold down Shift, it'll constrain that to keep that cube shape. Similar to resizing a photo, if you're familiar with that, where you hold down Shift to keep the dimensions of that image in place. Same thing applies to 3 dimensions. So those are those white boxes, and then we've got these little black boxes that are kind of centered at these intersections. So we can grab those and real cleanly just extrapolate, drag those out. Sorry, was there a question? I heard a mic off.
Totally. Your mom's coming Friday. Totally.
I don't think that's on purpose. Also, if I click on this, there's these rotational tools that pop up. And if I view these from a few different angles, I can grab those and I can rotate my cube. So I've got complete control over these 3D objects and how I want them to look and shape and sit and rotate. If I made a mistake, say I didn't mean to do that rotation, I'll just undo this a couple steps. And we're back the way we were. So here's our basic die. So I'm going to grab our die. I'm just going to move it over to the side because I want to show the concept of holes. Because this is a real powerful way to be carving and building your piece. So let me bring in one more box. And real quick, I'm going to stretch this out so that it's less of a box and more of a door, I guess. And we'll put a window in this door. How we would do this without a way of carving out negative shapes would be pretty cumbersome. We'd be talking about building this and then building another one over here and building another shape over here and kind of building the positive shape around a hypothetical negative space. Not a very intuitive way about it. So here we've got this almost flat box, and I'm going to grab one of these. And let's bring this cylinder in. So here's my cylinder. And anything that's solid can be a hole, and anything that's whole can be a solid. So if I wanted this to be my hole, I would just change this from solid to hole. And it gives you that transparent kind of zebra striping. So leave that solid. And this cylinder is defined as a hole, but I could change it back to a solid. Leave it as a hole. And I'm going to drag that hole to where I want the negative space to be in my board here. So that's sitting there. And if I hold down Control again and click to see this, I can see that it comes all the way through the bottom of this. It wouldn't have to. I could pull this up a little bit, and now we don't see it peeking through the bottom because it's, if we look very closely from the side, we can see that it only goes about halfway into my piece. I'm going to grab that arrow and pull this down so I can clearly see that it absolutely intersects this piece. It's not a hole yet. You can't see through it. So our next step is to click the two objects. So we're going to click one, hold down Shift to click another. Now they've both been selected. Do that one more time from a different angle. Clicking this box and then holding down Shift to click another box. So now I have two objects selected. In my toolbar, near the top of the right, I've got some new options up here. And I'm looking at this one called Group. And a lot of these things you hover them over and they'll give you the keyboard shortcut. Allows you to become a power user once you're accustomed to the software and the interface. When I group these together, it's going to turn these from two individual objects that are intersecting into a single object. And that hole cuts that hole right where that hole was. And now we've got a negative space inside of our physical space. If I make a mistake, it's difficult to recreate this without starting all over, but we can always just undo. And now it's back. Now that hole is a separate piece from the solid piece. But if we group them again, it will create that intersection, allowing us to create windows, create all kinds of negative shapes in our designs. So let's pull that out and apply that same principle to this die. So my die is going to have, it's going to be a very traditional die. So it's going to have the little inverted divot dots in the piece. Let's get a good angle on that. Let's bring in this sphere, because that's really what I'm looking for is like a divot. But if that were a positive shape, it would be a circle. So that looks, that's a great shape. Let me pull that up. And I'm going to grab this corner and hold down Shift so I can scale this down to an appropriate size for what this divot is going to be. And this is really where it starts feeling like IKEA furniture. It's how do I click? What's that keyboard command again to hold down Control and click to rotate it and view it from another angle. This is just part of building the intuition of using the interface. And the reason I said IKEA is that I always use this IKEA analogy because it's always true. If you've ever put together a table with chairs from IKEA, you know that first chair takes you 2 hours to put together. And it's frustrating. And you're trying to read that manual with the stick drawings. And then you get to the second chair and it takes you 15 minutes. Just because you've been through the process once, you know where things are, you're developing an intuition for how IKEA furniture is built. Same thing for interfaces like this. So we're just looking for, the point of that is I may be moving quicker than you're moving your first go. But be patient with yourself, and I mean, it does pay off. You do get efficient at it. Especially when we're dealing with 3D objects, because we need to keep viewing it from different angles, because what may look like a hole on the die from one angle can be a totally different experience from a different viewpoint. So we're going to try to move this ball so that it's sitting halfway in the middle. So first I'm going to drag it, and I think I'm starting to rough that in. I'm going to go to my cube up here and click top. So I'm viewing it absolutely from the...
Great. I wore walking shoes because I thought you might want to do that.
Somebody needs to mute themselves. Thanks. We're gonna grab this ball and try to line it up right in the top. And it gives you these hints. It tells you that I'm 0.7, it's millimeters, if you're curious. And 4 from this side, it does give you these cues to line these up, but there's also these alignment tools up here.
Yes.
So there's a mirroring tool. So if I select that, hold down shift and select the other one, I can also grab these alignment options. So I can align that up just by clicking those center pieces. It's directly above it. And because I've used the align options, I know that it's exactly centered on both sides. If I rotate that, my alignment tools are still on. So if I were to click any of these dots, it will, so if I did that, we cannot see the dot anymore because if I turn this into a quick hole, it's exactly in the center of my piece. So let's undo a couple steps and get our ball back. So we know our ball is directly centered. Now we're going to just click it and grab our arrow and drag it down about halfway. You can see that ball is halfway cut. And I can click on one of these sides, kind of get a different viewpoint, but let me zoom in. That's looking pretty good. I can always click on a solid object and turn it into a hole and see it transparently. And I get a good idea. That looks great. I mean, between myself using those alignment tools and then just eyeballing that ball to be halfway cut off, we're in good shape. Now, is this an appropriate die? Not yet. This needs to be the invert of that. So I'm gonna, again, click the two objects and hold down shift to be able to select them both. And I'm gonna make a mistake on purpose and then go back and fix it. So I selected both of my shapes and then I grouped them together. And now it is a single object with that little nub hanging up there. Not what we were looking for that die. So let's undo a couple of steps. Go back to this where they're separate objects. And I'm gonna turn that ball into a hole. So now it's still intersected, it's still in there. And now when I select both of them, again, holding shift and clicking both and grouping them, that hole has now created negative space in my solid. And I've got my first side of my die done, which is great.
Yeah, is that okay?
All right, so our next step is to move on to the second one, which we'll do manually, and then we'll start duplicating and make quick work of the other sides. Then we'll see if we've got any questions, and then everyone's going to start over by creating a unique die with their own unique way of representing the 6 sides of it. We'll roll through that, and then we'll start on our second project. All right, so there's a couple of ways I could approach this. I need to do side 2. And one thing that you need to know about die that most of my students don't know until they, I usually let them make the mistake and then correct them, is that people don't always understand that dies are uniform and that each side of a die has is the same if you go from die to die to die. And the secret to it is that the opposite sides of a die add up to 7. So if 1 is over here, 6 is going to be on the opposite side. 2 could be here, or it could be here, but the opposite side of it needs to be 5 to add up to 7. And then we do 3 and 4 on the alternate sides. So if you didn't do your die research before you went in and started 3D modeling, I may have saved you a couple of hours of having to redo your die because you just started putting dots everywhere. All right, so let's clean that up. So I need to, let's do side 2. And I could just build that into the side, but I find it always easier just to be building on top. So I'm going to click my die. We're going to rotate this, and I can type in a number. I've rotated it 90 degrees. A little hard to see visually when you're not the one doing it because it happens so instantly. So I will also just drag this over. And then get it to 90 degrees. And now my side 2 is facing up, which is just easier for me, my personal preference on modeling, things like this. So we'll bring in our sphere. Again, we're going to resize this so that it's a little more of an appropriate size. I'm going to use those arrows. So the arrow will drag it up and down on the height plane, the Z-axis. And then you could just click and drag and it's anywhere on the XY. So I pulled it down a little too far, but I can see it's starting to intersect. So I'm gonna
Hey,
pull that.
Clint.
Yeah.
Could we just copy the sphere from side 1?
That's exactly what I'm going to do. So we're going to do, I was going to do side 2 the long way and then start replicating it for 3 and 4 and 5 and 6.
Oh, okay. Okay. Gotcha. Thank you.
So yes, absolutely. Work smarter, not harder. So let me grab my second one in here. That looks about where I want it to be. Now the problem I'm going to encounter, because I didn't copy and paste that first one, is that these might not be the exact same size. So copying and pasting also builds in consistency when you're building multiple objects that need to be similar or the same. I'm not going to fix that for right now. If I were going to do this and really 3D print it, I would absolutely take the time to ensure that everything is uniform. So my number 2 is in there. My second one is going to go here. So I've got one. Bring it up a little bit. Oh, that looks good. Again, I'm going to set that as a hole. It won't create that hole until I group it, but we want to add in our second one first. So I'm going to click on that hole-shaped sphere that's here. And I can do a Control-C, Control-V, typical keyboard shortcuts work for this, or we've got our keyboards up here. So we've got a copy, which is great because we can copy and paste it. And then we've got a duplicate, which has a little more power behind it. Which will make more sense when we get into shapes where we're duplicating many, many at a time, like anything after 2. All right, so let's copy and paste this one. All right, so just placed it right in there, and then I'm going to place it. I'm just going to kind of eyeball that. And again, rotating it around, view it from a couple of different angles. Make sure it's really where you want it to be, not where your perception happens to be from the angle you're looking at.
I think everybody needs to just
that
stop talking and just draw it.
was just intuition. That worked out great, but it might take you a couple of tries to get that lined up. You won't get it the first shot. So we've got our 2 holes in there, and I've already copied the one, so I've got the one still in my clipboard to use for another side in a little bit. But let's hold down Shift and select both holes, and then select our cube, and let's group those together. And that's looking really good. So now let's rotate our cube again, and we'll do another side of this. So let's do the opposite of 1. Let's do a 6 over here. Because remember, your opposite sides of your die need to add up to 7.
I hope you guys are
Grab my cube again, and I'm going to rotate. I'm just going to type in 90. And it rotated. My 1 is down here now. My 6 is going to be on top. Because I still have that sphere copied, I'm just going to paste. And it does show up. I'll have to drag it up into position. And let's find a good place to put it, because it's going to go 1, 2, 3, 4, 5, 6. So bring this over. That was pretty lucky that it just happened to line up halfway. All right, so I grab that, and instead of copy this time, we're going to duplicate. And this time it placed it in the exact same location. So now I've got 2 sitting on top of each other. So I'm going to bring 1. Oh. Pull that one over. And now we've got 2. Not bad. We'll do it one more time.
So here's a little part in your hair.
For our third. And I'm going to grab all 3 of them, nudge it up a little bit, make sure all 3 of them fit. That looks pretty good. So now let's hold down Shift, and we're going to select all 3 of these. We'll duplicate that one more time. We'll bring all 3 of them over for our 6th side. Now we need to, of course, group all of these so that those holes actually intersect and cut into our die. I'm going to take a quick shortcut and just Command A, which will select everything, because I know that this is everything that I want, and I want everything that is on my current work plane to be grouped together. And I'll do a quick group. And now I've got, my die is already half done. So I've got 1, 2, 3, 4, 5, 6. And any pressing questions while we're going? Can we just copy the sphere from side one? Yes. All right, so the goal for the next 10 minutes is for you not to create a die with these divots, but to create a unique die that represents the 6 sides in a unique way. And that could be letters from the alphabet. It could be 1, 2, 3, 4, 5, 6 things that you put on each side. Again, I've seen actual numbers sculpted and put on here. I've seen numbers represented in different languages. Braille was a great example that I had shown. So let's go until 1350. So you've got 9.5 minutes to construct your die with a unique way of communicating all 6 sides of it. And if anybody wants to share at that point, we'd love to see your die. What we got going in the chat? Why do you like Tinkercad rather than Onshape or Sketchup? They're very similar. Great question, Amanda. I think the main reason that I like Tinkercad is because it's part of that AutoCAD ecosystem. So if I'm working with students that may be on an engineering track or an architecture track, they're going to reach a point in Onshape or Sketchup and Tinkercad where they just can't build any more complexity into the projects. And what's great about Tinkercad is that it's part of the Autodesk family. Autodesk being the creators of AutoCAD, which is the top industry standard of creating 3D models for engineering and architecture. So a lot of the principles that happen in Tinkercad just relate as you go up. But also in Tinkercad, if you outgrew Tinkercad and you're doing more than your web browser can handle in here, we could send this to Fusion 360. And it'll take your 3D model, package it up, and bring it to a more sophisticated software so it scales along with you and you continue to build that up. If you get into Fusion 360 and you put a couple of years into your 3D modeling career and outgrow that, then you graduate to Autodesk, which has a hand in so many of the things in our infrastructure on this planet that we take for granted. Almost like concrete. But part of it's also personal preference. I mean, I love that Tinkercad has been web-based and it's easy for me to jump in and import and export 3D models from other applications that I work with. But if you prefer SketchUp or Onshape or any of these other tools, I mean, it's always about using the best tool for the job. I still use Photoshop for a lot of Photoshop work, and there are people who say, oh, GIMP is better or do something different, and it's, yeah, of course. Use whatever tool is going to allow you to be creative and collaborative. So Tinkercad's not the only game in town, but it is because the classroom feature of it is really powerful to be able to facilitate classes and view other people's workspaces that are joining your class, but then also that scalability into more advanced 3D modeling software. But different 3D modeling software have different nuances and can do different things. Tinkercad is definitely totally different than Blender, which is dealing with animations and special effects. And it's a robust package that is much more than just 3D modeling. It's not uncommon for people that are working in this kind of industry to use one type of software for the 3D modeling and then bring that over to another piece of software and handle the lighting and bring it over to another piece of software and handle the rigging and animation. Those tasks aren't typically done by the same individual. It's usually a team and there's specialists in each one of those areas. But those workflows are dynamic and changing depending on projects, depending on teams, depending on organizations. But the philosophy of 3D modeling that we're exploring today is going to be true no matter what platform you use. Yeah, Autodesk Maya is another big product. And Jesse's preference is Autodesk Maya over Blender, for sure. And if we did a poll of 3D modelers, we would definitely find people that prefer Blender to Maya. And there's a lot of tools out there. There's a lot of people that specialize in certain tools, and there's a lot of people that know a variety of tools so they can choose the best tool to use for whatever project's coming down the line. A tool for architecting a building might be a different tool than using a tool to design a sewage system or to design a die. Yeah, and sometimes it's just personal preference. Sometimes there's just something about an interface that turns you off and you never go back to 3D Max or SketchUp or something. Or you don't come back to Tinkercad because you don't like that you've got to, I don't know, hold down Control to rotate around. But Tinkercad's pretty intuitive for anybody to just come in and start 3D modeling, where some of those more advanced softwares have a learning curve that can turn people off. All right, how are we doing? Anybody got a die to share with us? I can, I think I can give you that permission, or our mod can. Yeah, thanks, Jesse. I mean, if you're coming in with an Autodesk Maya background, you're probably finding this to be pretty 101, but I think you can at least appreciate how quick and accessible it is, that it's no software to download or license to deal with. I mean, it's a free, open source, web-based product that is available to anybody. I've done 3D modeling workshops similar to this in schools and in villages and small groups all over the world. So I started doing 3D modeling teaching in India probably 8 years ago, and then migrated that when I moved to Turkey 4 years ago, and now doing it in Denver. So it's worked across a variety of technologies and infrastructures and understanding of how things work. So it's very, very, very flexible. Okay, iPad works better with the Apple Pencil. I agree, almost always, not exclusively to 3D modeling, but yeah, using the Apple Pencil with the Bluetooth connection with the tactile tip to it will give you a finer control of things if you're doing this on an iPad. Maybe if you've already said this. No, there are no licenses. Tinkercad is free to use. So it's just a matter of signing up and you're able to jump into it. You might bump into license restrictions if you try to import a 3D model that you don't have permission to use, that kind of thing. Oh, I got another question. Is there a way to fill in that negative space made from the hole so it's a different color from the cube? There's not, because once you group them together, that sphere is no longer its own piece. It's been merged together and have become the same shape. So all you're going to have is kind of the lighting to indicate that, or if you catch it from the right angle, like we can see my one has that shape into it. But yeah, if you're looking straight down onto it, is it 100% clear that this has a three-dimensional divot to it? Maybe not from that angle, but as you come from here, you can start seeing that things do have that dimension and depth. All right, everybody doing well? Anybody have one they want to share with the group? I love seeing the unique creativity that comes out of something as simple as design your own 6 sides to a die. It also usually opens up a conversation into, wow, how'd you do that? And then we've got teachers or students teaching students, and it almost becomes a flipped learning experience organically, which is super exciting, I think.
Right now, I'm just trying to get through all this drawing.
All right, we'll give it another minute, and then we're gonna design our own identification tag that we could then 3D print and put on our luggage or a suitcase or a backpack or your keys or anything that you lose. Is it possible to export in USDZ format? Wow, my favorite format. It doesn't export it in USDZ, but it does export it as an OBJ or an STL. GLTF, the .glb file, converts into a USDZ file really easily and smoothly. So while it doesn't natively kick out a USDZ file, you're a Google away from exporting this GLB, uploading it into that website, and it kicks out a USD in 1 second. And then you can throw it into Reality Composer or whatever it is you want to do with your USDZ. Didn't expect to hear that extension happen in this workshop, but thrilled to hear it. All right, we've got a studded die sent in. Let's take a quick look. Wow, that looks impressive. Many more than 6 sides. It immediately reminded me of Bowser from Super Mario Bros.
So you guys, we have 10.
Can you manipulate individual vertices? Yes, but probably not the way that you're meaning, just based on your use of the word
Good thinking,
vertices.
everybody else.
We can come in here. We can't sub-segment the vertices and then extrapolate individual planes that we create from that.
Well,
Jesse,
this
if
is our
that's
last
the
10 minutes
question you're asking.
together. We don't have a class.
You're ready for Fusion 360
So-
or Maya. You're already too advanced for
This is
Tinkercad.
our last class, buddy.
All right, so let's take our die. Let's move over to the side. Let me just look at my notes, make sure I didn't miss anything that I meant to bump into. We talked about all of this
All
stuff.
right, let's draw Bingo. We only have 10 minutes, so let's draw Bingo.
Let's
real
view this
fast,
in
and then you guys
augmented
can
reality
color
before
on
we
your own.
replicate something else around us.
Oh no.
So here's my
So
die
Bingo
here.
drawing Bingo.
And what I'm going to do is I've got Tinkercad already installed on my iPad. So I'm going to open that up. And again, because we're not saving anything, all of this is
Let's draw Bingo,
cloud-based.
'cause I know
So
you
I'm
guys
going to go into
really
my
wanted to.
Tinkercad and I'll share that screen in just a moment.
Yep. You can
And
have
we'll see that
color
my
on your
project
own.
is already here. So let me just check
All right,
that
Here we
chat.
go.
AR
Starting
quick
with a
look.
big overview.
It's not a USDZ file, so it's not AR quick look on the iPad. It does need to go through the AR and the Tinkercad app on the iPad.
Okay.
But for those of you that know what I'm talking about, we could export that GLB file, convert it into USDZ, and then if we were to open that USDZ on an iPad, it would natively just open as that 3D model. So yes, but all right, let me
Now, I'm gonna go
swap
ahead
my
and
sharing.
coming out from the middle of the eye on the side here.
So,
And then have a line coming out.
Here comes my iPad.
Yeah, it is.
We're now viewing my iPad screen.
All right, now this-
So this is my Tinkercad app. And my first project is right here. It automatically synced
No,
up.
there's
So I'm
not
just going to
glasses.
enter that project.
I don't know, Vivian,
tinker
who were
this.
you talking to?
And here I've got my Apple Pen, so I could be doing more 3D modeling here. We can see it's loading. So if you looked closely, you saw the spheres appeared and then they disappeared.
All right, so
That was
this is
Tinkercad loading all of the
nose.
assets and then
So I'm
merging them
gonna go
together
ahead and
into what we
color
currently
this.
have. So I am able to rotate this around on my iPad. But the one extra piece that comes with this is in that top corner, we've got AR Viewer. So it's built right into Tinkercad itself. So I'm just going to tap that. It's starting it.
Oh, no.
It's looking at my surface. So this is the table where I'm working. And I can select it when it's where I want it to be.
Now I'm gonna do his
And
mouth.
it's there, two sides. I can pinch and open and make it the size of my room. But now I can also walk around this cube and I can view this as if it's a real prototype in my real environment and get a real good look at all the details of it. I'm getting super, super close. There's those divots. Those divots are a lot more visible in the context of the 3D world that it's in.
All right, now I'm gonna put some teeth on them.
There's a cup. That's a huge cup, by the way, if the scale of that blew your minds. So pretty great. I mean, we can automatically do that. We can just drop that in. We can take a photo of it if we want to save that and send it to somebody. Super
That's what we're
intuitive to be
trying.
able to view it immediately in AR just using Tinkercad. There definitely is a workflow to view in AR in other ways. I could have exported this and then imported it into CoSpaces or again, use that USDZ file and Apple sees that immediately. A lot of workflows that get to it, but super nice that Tinkercad includes it right
Try to just follow
in the
it
app for us to do
because
immediately without any
we've already
importing,
started.
exporting, and all that workflow that could be super messy. You can't do that in Onshape. Not yet. I'm sure they're working on it. But yeah, it is great for prototyping this. A lot of times when you're doing 3D modeling, you're often doing it for 3D printing. Ultimately, which is usually seen as the way of prototyping something, is that we're going to 3D print it before we mass produce it. And this almost allows you to prototype something. You can prototype it in augmented reality, see if there's anything quirky about the design that you weren't seeing from just viewing it here in the workplace, make those changes, and then send it to the 3D printer and continue to refine that prototyping process. So it definitely can be a big part of that workflow of refining this and refining this. All right, another question. The bottom left corner clear ball on the workplace has a function? I'm not sure I understand that question.
Now we're about
Oh,
ready
what
for
function does it serve?
body.
There's a sphere on the bottom left. On mine?
Over here, start right behind.
I am
behind
not-
This eyebrow up here on the left. and then the
I'm not
right
seeing what you're referring to,
eyebrow
that clear sphere on the
past
bottom
the
left.
base of that bar.
It may be. You may have brought in a sphere or copied it and then not realize that you copied it and pasted another one and then had an extra one laying around. If that were to happen, just click that and delete it. Let's get rid of it. All right, we've got 20 minutes left, and I definitely want to jump into another project just to advance this a little bit. So let's grab our die and we'll just drag it over a little bit. And I'm going to give you a choice. One, you can create that name tag real quickly. You would probably rough out by just grabbing your cube, creating that space for it, coming in here, pulling in some text. My text is going to be, give that some yellow, and then place this on here, and then group it, and then put a little place on here, put in a negative hole, so there's a place to put a little loop or a hook into that so that it toggles onto your shoelace or your zipper or something. So your option is to do that, or if you want to do something a little bit more advanced, take a look at the room around you and find probably a piece of furniture, something that's not too complex, but something that's definitely made up of a couple of different objects, different shapes, and see how closely you can recreate that chair or that fork or that lamp that you have that you're looking at. This can be really powerful too, especially when we bring it into AR and we can show what that lamp looks like next to its actual lamp and how close did you get to the mark and where is it missing. That's a great way to provide feedback for yourself or for others. So I'm going to be working on a wooden bench that I have here right by my workspace. And then when we're ready with it, I'm going to augment it and we'll see what that looks like. And I encourage you to do the same. So you can play along and try to build that in Tinkercad, or you can just watch my process and how I do it. And I'm just checking my notes. Great. All right, so I'm working on my workbench. And my process is often to look at the object. So my workbench, it's got a flat top, and then it's got two legs that come down, and it's got a brace bar in the middle, and it's got some unique shape to it. But I always sort of start with, well, like, what's the principal piece of my object that I'm creating? And in this case, it's going to be that the sitting part of the bench, which is the biggest part of the bench. So it's big, it's obvious, it's a quick and easy shape for me to pull that out. And if I wanted to get super precise, these are numbers in millimeters. You can change that grid, you can change that scale. So if you were really going to 3D print this and you wanted to build this super accurately, that power is there. But when we're building things for fun like this, the scale isn't critical, but could be. So here's my bench. I'm going to raise it up a little bit because people are going to be sitting here with the legs down below. It's nice that it gives us this artificial shadow. Again, the struggle of interfaces to replicate 3 dimensions on a 2D screen has come so far, and it's the little details like that. All right, so we've got that, and then a lot of times something's going to be a similar shape in one area or another. I will duplicate it, so I don't have to worry about that width being different. I'll rotate that 90 degrees up and down. Grab my white box, just drag down that size, and I want it to intersect with the bench part of it, but not poke out the top. So I'll be pretty careful with that. And then just bring that into place. It doesn't reach all the way to the edge. It has that little lip that hangs over. And that was pretty fortunate that I got pretty close with it. First shot. All right. This is definitely going to be duplicated because it's going to have the same leg on the other side. We'll grab that. And that looks pretty good. but as we view our perspective, it's not very good. It might have looked lined up and flushed at first glance, but as we view it from 3 dimensions in our 2D platform, it gets complex. So we'll bring that in. Yeah, if I were going to do this for real, I would get a measurement on the distance of this lip, so that's identical on both sides. But for this rough prototype, I think I can eyeball it. That's pretty close. That's looking good. We've got another horizontal bar that comes in here. It's like a support beam for this. It's similar to top shape, but not identical. So let me grab a duplicate of that, drag it down. And for this shape, it's actually quite narrow. A little bit taller and centered right in the middle. It doesn't come out to these edges. So I could bring these pieces in, but instead of doing that, I'm going to bring in a hole and just cut it off, which might not be the most efficient way to solve this problem, but I just wanted to show a couple of different ways of solving that problem. So I'm going to grab that box, raise it up, view it from the side. We're going to bring that in. And view it from the other angle, it didn't quite intersect with it. So let me grab this, pull it in. Once you've got it selected, you can also use your arrow keys, which will give you a little bit finer control of this. It's okay if it intersects with that leg because I'm not going to cut off the leg, just this barrier bar. So I've selected this hole, selecting that support beam. I'm going to group them together and cut that right off. And because it intersected a little bit inside of this leg, the cutoff of that is happening inside of the leg itself. So we don't see any seams over there. For this side,
I'm late.
I'm gonna grab that black box in the center and pull it in until it disappears. That is looking like my bench already, as you'll see in a moment when I augment this. There's one little thing I need to do left with it, which has these little decorative flares on the sides. So I'm going to find a shape that's similar to that. That round roof is so nice that Tinkercad created that for me. I certainly could have taken a cylinder and cut that in half and gotten the same piece, but this is great too. So we're going to drag that in. It's about halfway, then it intersects. It doesn't stick out like that. So I'm just going to drag this piece in. That looks very similar, as you'll see in a moment when I augment this, to how we want this to be looking. So I grab that one and duplicate it.
You want to draw another anime character?
Put it on that
Is that
side.
what you said?
I'm going to grab both of these, duplicate them. Just using my arrow keys. Just pull that over along that way. That looks pretty good. We see there are multiple colors, but when we group them, so I'm going to hold down, I could hold down shift and I could click every single one of these objects, or I can hold down shift and lasso over them. Now we want to be careful because I grabbed this die back here also. So watch your 3 dimensions. Bring this over a little bit so I can get a clean lasso around this whole piece. And if I group that together,
does that look good to you?
that's pretty nice.
Okay.
Let me undo that, because one thing you may want to do is retain the colors that you've chosen when you group things. And by default, when you group things, it just inherits the base color from the first object and makes them all that color. But I could select these. I could toggle this.
Perfect. All right, let's do this Todoroki first because I think it's a little.
If I choose that color shape, there's one down here I can choose as multicolor, which doesn't do anything right now, but when I group it, now they're grouped and retained that multicolor to it. And we can see there's a little glitch down here where the leg didn't quite come all the way down to the ground. That is something I would definitely want to clean up before I send it to a 3D printer or somebody for feedback. So we can do that. So let's change that back. I do want it to all keep one color. And I'm going to select this die, remove it from here. So I just selected it and deleted it. And 1 second, because now I'm going to pull this up on my iPad version of the app, and it's automatically synced over, so I didn't have to mess with anything. And before we do that, I want to make it the same color as the bench we're going to be looking at.
All right. So when we're
Okay, got our bench.
Just a reminder, we've got about 10 minutes left.
Perfect. This is our last thing, and then we're going to go to our follow-up slides. So perfect. So let me share my iPad screen over like I did previously.
He does have like a long on his chin, so I'm just going to put that in right now.
Here it comes. Now you're viewing my iPad. There's that same thing that I created, but now we're on the iPad version of it. Let's go into AR mode. There's the bench. And we're going to place that bench right there. Again, pinch to scale it up. And what do you think?
Let's go ahead and
pretty close. Definitely some details, especially when we get down here that we can look at together. I thought that that table leg went down too far. Turned out it didn't come up far enough, and I need to create that negative space in there for that to be sitting on. But for the most part, the rest of it looks really similar. That sort of support beam is in there and looks appropriate. I think that lip is hanging off maybe a little bit more in the real version. You can see there's another brace piece in that corner that I would want to create in this corner. Yeah, this is a great, fantastic way to jump in here. Prototype, check out what does this look like in the real world? Is it getting to where I need it to be? And already I've listed off 5 or 6 things that I need to adjust and make changes to. The power of instant augmented reality is here.
It's like a weird
All right.
and it's
And we'll hop back. Those were our 2 projects. Anybody have anything interesting to share they've created? If not, I've got 3 slides left and then we're free to go. So congratulations. If you weren't a 3D modeler coming into this, you are a 3D modeler now. So now what? I think building these types of projects and thinking of little innovative projects to build just continues to refine your skills doing this all of the time. Even just teaching this makes me better at this. So learning by teaching is powerful. So 3D models are mostly by their very nature open source because they really are a bunch of math. If we were to take this 3D model and actually look at the code behind it, those vector codes, we would see points and we would see a logic connecting points together. I mean, that's how all physical objects basically work. Is that you can break anything down to geometry. Sometimes that's a complex geometry, sometimes it's a simple geometry, but it's all just now you'll be looking around your physical world everywhere you go, and you'll see the you'll see the shapes of things. But because these are open experiences that scale and don't lose quality as you enlarge them or move them from place to place, you can put them into virtual reality. You can put them into another augmented reality project. You can 3D print these pieces. You can push that augmented reality experience into your learning management system, like we're doing with those Usdz files inside of Canvas. It's just super scalable. A lot of these things that we can be talking about can replace the 2D presentation materials that you have in a lot of your learning materials. I mean, if you're giving somebody a book or a website or even just a handout, it's like, hey, here's this table, and you need to interpret it as a 3D object instead of it actually being a 3D object. I mean, this really can shift the paradigm of how we provide content back and forth, especially when we get into interactions. Our future, what we're thinking about doing, what we are doing in the School of Dental Medicine is not only are we sending these USDZ file augmented reality experiences so that students can see that tooth model on their desktop in front of them, wherever they happen to be, but also they can make modifications to that model. They can add labels to that model, identifying parts of that tooth or that instrument or anything, and then send that model back to a course instructor to give them feedback on that. I think the biggest mistake we can make with all of this XR, VR, AR stuff is creating passive experiences with it. The power really is in collaboration and creation and making of students being able to do something and then sending it back to you. If this is just a replacement for watching another screen and watching another video, we're doing a huge disservice to the technology and the potential of it. This allows us to put augmented reality all around us. Pokemon Go is just a bunch of 3D models and they exist all over the world because part of that 3D model logic also contains what its GPS coordinates are. So we could do this all over our campuses. We could create huge scavenger hunts with students walking around with their iPads or phones and finding objects to better understand their campus or better understand each other. Or to one experiment that we did in Istanbul was that we created a scavenger hunt in our school. And you would come to the wall and you'd need to know, do I turn left or I turn right? And for the French students, they had to look at the wall through their augmented reality and they needed to be able to read the French instructions to know that they turn left or they turn right. And they had to do this 5 or 6 times to navigate and find the prize at the end of the game. Really gamified learning through augmented reality, just by positioning these 3D objects according to their GPS coordinates. And you can build these Pokemon game-like games anywhere in your physical location. And of course, anything else you can think of. This is the tricky part about these kinds of conversations is that they scale also. I mean, we could be talking about so many flavors of stuff that could come out of this. Yeah, 360-degree photospheres are an awesome thing to bring inside of maybe a VR project, or bring your 3D model into something and then say you did a 3D model of the Eiffel Tower. Well, that would be great to see in your backyard, but it might also be cool to see that in a 360-degree view of Paris and see it maybe next to the real Eiffel Tower. Super powerful. Iframe embed of 3D models in the LMS, super useful. Absolutely. Thing with the USDZ files is you don't have to iframe it. You could just put the link to the USDZ file in there and they tap the link and it opens up in front of them. Yeah, super powerful. You know, we're all from different parts of the world, perhaps. I don't know where everyone's physically located, actually. The byproduct of remote conferences. And I know our schools compete for students and staff and resources, but I think at its core, us as educators are all on the same team. So I hope this starts a conversation of us continuing to work on these types of projects together instead of just in our isolated silos of university or education. So if you believe that also, and you want to talk about a project you have coming up, even if you just want someone to bounce an idea off of who speaks the language with you, or if you want someone to help you build out a lesson plan, how do I integrate this into an existing lesson plan? How do I build this into a curriculum that already exists? How do I make this as low barrier for everyone I'm introducing this to? Let's talk about it. I've had lots of conversations with schools all around the world about this, where we start talking about 3D modeling or VR and they think they need a $50 million budget that's going to reoccur. And it's like, no. We've got free web tools that do this. And if your students all have phones and you think that there's a phone epidemic going on at your school, reframe that and realize you've got a one-to-one VR program in your school right now. You just might not know it or know how to build the workflows around it to harness that energy. You know, there's 5th graders with phones in their pocket that are more powerful than the computers that sent the first humans to the moon. So there's a paradigm shift, I think, as to how we think about students and their devices. Here's my contact information. I'm also in the Discord for the rest of the conference, of course. But if you want to reach out, I love seeing projects pop up on Twitter that I had a hand in guiding early on, so that's always fun. So include me in these conversations, even if it's just because I have genuine interest. We've got 1 minute left. We're out of time. We can take any questions that we've got. If nothing else, have an awesome conference. I will definitely see you over the next couple of days, and let's keep this momentum running. I know there are tens of workshops that you could have joined. There's a huge agenda. You did not have to choose this one, but I appreciate that you did. So with full gratitude, have an awesome conference and a great afternoon, everyone. Thanks.